most of our knowledge about early developmental events or embryology has been derived from using the mouse as a model because it's easily accessible and amenable to being genetically modified. However, in our study, we have for the first time applied functional genetic models to cattle embryos. In our paper, we describe some critical differences during early mammalian development between mice and cattle. So far, all work has been done on the mouse. The reason is that it's extremely difficult doing such work in cattle. The actual molecular tools to genetically engineer cattle embryos simply do not exist. In this aspect, we had to go back to the beginning and reinvent a molecular toolbox so that we could do functional studies on cattle embryos. Now, every gene is turned on by a switch that is hidden in the DNA. We exchanged these switches for a critical gene, so we used a mouse switch in cattle and a cattle switch in the mouse. And then we examined whether these behaved in an identical way to their native organism. It turned out they did not. Why should this be important? Well, not only does it mean that the mouse isn't always the best mammalian model, but that we need to look also at other mammals to understand early developmental events. But this work has also repercussions in human medicine, because this gene OCT4 is extremely important for the establishment of embryonic stem cells, which have incredible therapeutic value in human medicine. Lastly, our work is of course extremely important for the cattle field, because we are now for the first time understanding how the cattle undergoes early embryogenesis. And clearly we cannot go on using the mouse as a model for cattle and to understand why we get such high levels of embryonic death in dairy cattle. We need to establish the cattle as a bona fide embryological system and thus find out what is crucial to embryo survival.